Please make sure you have your guided notes ready. Make sure you have your pencils and pens, and just in case we need to do some highlighting, and you're in a quiet place and ready to go. I'm going to try and keep this one brief. Our essential question for today is, how can you represent the probability of compound events by constructing models? And actually, some of this you've already been introduced to. So let's go ahead and get started. All right, we got a couple of vocabulary terms, and the first one is a tree diagram. And a tree diagram is a tree-shaped diagram that illustrates sequentially the possible outcomes of a given event. Now, up to this point, we have been working with simple events, and that's just where you have one event, like flipping a coin or rolling a dice. When you get into tree diagrams and two-way tables is when you actually have a compound event, or you have two things that can make different bunches of different outcomes. All right, and a tree diagram looks much like just a factoring tree that you did in 6th grade, and it's going to help us to display all the different possible outcomes. All right, a two-way table is the second vocabulary word, and this is a table that displays the possible outcomes of compound events. And you've actually worked with two-way tables before, but I think most recently you've called them Punnett squares. And so these are just like your Punnett squares that you did in science when you were studying genetics. And then finally, compound events. These are any events which consist of more than one outcome. So we're going to be working with two different things that are going on. All right, if you need to pause the video, go ahead and do so and jot down the vocabulary. Okay, here is our first example, and this is kind of going to show us how to make a tree diagram, or what a tree diagram looks like. I will say before we get started that your turn questions are sporadic throughout. They're kind of mixed in with the examples. So when you get to your first your turn question, just don't think that you're done. There's more video to watch and more examples to go through. So anyway, let's get started. All right, the first one says you are ordering a fruit smoothie. You have your choice of a small, medium, or large smoothie, and you can include one of the following fruits: strawberries, bananas, or oranges. How many different choices of smoothies do you have? All right, and so here is an example of a tree diagram showing the different parts. And I want to kind of break this down just for a second, just so you have kind of a clear idea as how to go through and work these. And there are more than one way to do this, but just so you have a clear indication. Here's one way that you can set up a tree diagram. This is kind of horizontal. You could also set this up vertical. But notice in our first kind of column here, first row, we have our first choice. So it's almost like we put choice number 1 is the size. All right, so our first choice, you should be writing this in your notes, is the size. All right, and then our second choice is going to be the flavor, basically, what we want to put in there. Okay, and so what I have is I've listed out my first choices, which are small, medium, and large. And then from my first choice, I have to list each of my second choices. So I could have a small strawberry, a small banana, or a small orange. I have to repeat that again for the medium. I have a medium strawberry, a medium banana, or a medium orange. And then finally, same thing for the large. So I could have a large strawberry, a large banana, or a large orange. And so my total possible outcomes are going to be the different sizes matched with each of the different fruits. And so off to the side, I've kind of rewritten these, but there are 9 possible solutions. All right, I have 3 choices of size and 3 choices of flavor. And I end up with, showing on the tree diagram, that I have 9 different choice smoothies. So again, this is one way that you could set this up. Let me show you another way. All right, here's example 2, and this looks a little bit different, but let's go ahead and look at this situation. This is a little bit different. It says you'll be attending 2 sessions at a science camp. At each session, you will be assigned to one of the following groups: red, green, blue, or yellow. If you will not be assigned to the same group for both sessions, how many group assignments are possible? All right, well, first we have to take our first choice. All right, so now we're looking at a more vertical diagram. And again, this first column is going to be our first option or our first choice. All right, and in the first option, we could be in red, green, yellow, or blue or yellow group. All right, so this is our first option. From here, we need to branch off and do the other color combinations. Now, it tells us back here that you will not be assigned to the same group twice, all right, for both sessions. So, if I'm first assigned for red, I cannot be assigned for red again, which is why red is missing from my second option. All right, here's my second possibility. All right, so if I'm assigned to red first, then in my second week, I will be either green, blue, or yellow. I can't be red again. All right, if I'm assigned to green first, then in the second week, I will either be red, blue, or yellow. I can't be green. All right, and so on and so forth. If I'm assigned to blue first, then I can either be in the second week red, green, or yellow, but not blue. And then finally, if I'm assigned to yellow first, then I could be red, green, or blue, but I couldn't be yellow. All right, and so the final answer here is that there are 12 possible outcomes. That's my question. How many group assignments are possible? Well, there are 12 based on what the information given. So a tree diagram is simply there to help you list out the possible options. All right, here's one for you to try. And again, you cannot, don't stop the video after this just because there's a your turn question. There's still more to do. So you're going to make a tree diagram. You decide to get popcorn at a movie theater, and the popcorn comes in regular, large, and jumbo sizes, and you have your choice of plain or buttered. How many choices of popcorn do you have? So you need to create a tree diagram to display the information and to see how many possible choices you have. All right, your teacher will go over this with you tomorrow. Okay, if you're not quite done with that one, go ahead and pause the video, but we are going to move on. So using a tree diagram. Now we're going to talk about using a tree diagram to find out our possibilities. So here's example 1. To find the probability of getting at least 2 heads when flipping a coin 3 times, make a tree diagram to find the outcomes. All right, well, we've already made that for you, but we do want to answer the question. And so find the probability of getting at least 2 heads. So I'm flipping a coin 3 times and I'm getting at least 2 heads. That's what I want to look at. All right, so here we go. My first flip, my options are heads or tails. All right, my second flip, if I got heads on the first, then my second flip, I could either get heads or tails again. If I get tails on my first flip, my second flip, I would get heads or tails. So that's kind of why we're kind of branching it out like this. All right, so that's my second flip. That's my second row. My third row shows me my third flip. So my third flip again is either heads or tails. And if I got heads on the second flip, then I would have heads or tails. So that this could be read as my first flip, my second flip, my third flip, I got heads, heads, heads. All right, if my flip was heads, then tails, it would look like this, heads, heads, tails. All right, another option would be heads, tails, heads. So I'm kind of branching off and showing all the different possibilities that you can get on flipping a coin 3 times. So it does look confusing, but if you kind of keep reasoning it through and draw out a diagram, it makes it a little clear, okay? And so the question is, find the probability of getting at least 2 heads. So first I'm going to do the diagram. Then I'm going to go through and I'm going to look at my options, and I want to circle the options that have at least 2 H's, which stands for 2 heads. So I have at least 2 H's here. I have 2 H's here. I have 2 H's here. This one, I don't have 2 H's, so that doesn't count. This one I have 2 H's, but not here, or not here. Okay, and so the probability is going to be 1, 2, 3, 4. I had 4 favorable outcomes over 1, 2, 3, 4, 5, 6, 7, 8, over 8 total outcomes. These are the total sequences of flipping a coin 3 times. So I have 4/8, which equals to 1/2, all right, or 50%. So because 4 of the 8 outcomes have at least 2 heads, the probability is 4/8 or 1/2. And again, percents make most sense to us. So 50% chance of flipping at least 2 heads or getting at least 2 heads when I flip a coin 3 times. All right, here's another example. So you're choosing an outfit. You can choose a t-shirt, a button-down shirt, or a sweater. Okay, and I've given the letters here. So T means t-shirt, BD means button-down, or a sweater for S. And you have jeans, all right? So, and you have bottoms, sorry. So you can wear jeans, you can do dress pants, or khakis. So J is for jeans, D is for dress pants, and K is for khakis. The first thing we're going to do is make a tree diagram to determine the number of possible outcomes you can make. So again, here's kind of a visual representation of what we're talking about. We're trying to figure out how many outfits that we can make. All right, so here's what I come up with as far as my tree diagram. My option 1 is the shirts, and you could have done the pants first, it doesn't matter. And then from the shirts, I could branch off and show the 3 different types of pants that were possible, the jeans, the khakis, and the dress pants. All right, so the first part of this says let's find the probability that the outfit you choose will have khakis. All right, well, let's go ahead and look at that first. So, probability that the outfit we choose will have khakis. Well, I could have a t-shirt with khakis. All right, here's one option. I could have a button-down with khakis. There's another option. Or I could wear a sweater with khakis. And so I have 3 favorable outcomes. Remember, I'm still using my formula of favorable outcomes over total outcomes. All right, so if I set this up, I had 3 favorable outcomes over, well, I have 9 possibilities. All right, I could do t-shirt and jeans, t-shirt dress pants, t-shirt khakis, button-down jeans, button-down khakis, button-down dress pants, so on and so forth. So there are 9 possible outfits. And of course, I would want to reduce this to 1/3. And again, if I change this to what's more meaning to us, 33%, it would be a percentage. So I have a 33% chance of choosing an outfit that has khakis. All right, let's look at the next one. Now find the probability that the outfit you choose will be the sweater and jeans. All right, I'm going to change my color. So I'm looking for the outfit that's sweater and jeans. All right, here's my sweater, here's my jeans, so I'm going to circle that. And really, there's only one option here. It's the only option that I have sweater and jeans. So my favorable outcomes will be 1. My total outcomes will be 9. Because I still have the choices of 9 outcomes. And if I change this again to change it to a decimal and then a percent, go ahead and put the 1 in the house, just divide the bottom into the top. All right, I'm going to add a decimal and a 0. So 9 goes into 10 one time. I'll subtract, add another 0, and then I'm going to move my decimal. So I basically have 11% chance of choosing the sweater and the jeans. All right, here's a your turn question. And this one's talking about sandwiches, but it says you're getting ready to make a sandwich for lunch. You can choose a tuna, ham, roast beef, or egg salad sandwich, and rye, white, wheat, or multigrain bread. First, create a tree diagram and then use the outcomes to determine the probability that you will choose your sandwich that your sandwich you choose will be on multi-grain bread. So first thing you have to do is do your tree diagram, and then you have to go back and make sure, see what the probability is of choosing a sandwich on multi-grain bread. All right, your teacher will go over with that, so good luck, and we'll keep going. So don't, we're almost done here, but don't stop the video. We got a couple more things. Okay, now we're going to move to two-way tables, and two-way tables, since you just did this in your science classes with genetics, I think you should have a good understanding of this. But two-way tables, here's an example. It says, a two-way table is another way to display the outcome of compound events, okay, more than one event. The question from the previous slide about the outfits can be displayed in a two-way table. All right, so what we can do is we can create a two-way table that goes through and shows the options. All right, I'm going to put my first option here, or at least choice 1, which is going to be the type of shirt I'm going to wear. And then down the side, I'm going to put option 2, which is going to be the type of pants that I'm going to wear. So this is kind of like my first choice, or my first event, and this will be my second choice, or my second event. All right, and what I could do is just completely fill this in, and we're going to do that on the next slide to talk about the probability of different outfits that we would use. All right, so once you have that set up, then we can go ahead and fill in the blocks, and I'm going to show you that on the next slide. All right, so let's go ahead and fill in the blocks here so that we can create, finish our two-way table and then answer our question. All right, so again, it says that we're going to use it to determine the probability. And so in this case, I'm going to use my abbreviations. I think I called this T for t-shirt, BD for button down, and then S for sweater. And then over here I have jeans, and then khakis, and then dress pants. All right, and so I'm going to fill these in. So this could be a t-shirt and jeans. This could be button down and jeans. This would be sweater and jeans. This would be t-shirt and khakis. This would be button down khakis. This would be sweater khakis. All right, t-shirt and dress pants. This could be button down and dress pants. And this could be sweater and dress pants. All right, so now that I've filled in my options, I can go ahead and actually use this to answer my questions. All right, so first of all, it said, let's complete the two-way table and then determine the probability that the outfit you choose will have jeans in it. Okay, well, I'm going to grab my different color here. So I can look at my options and say, okay, here's an outfit that has jeans. J stands for jeans. Here's another outfit that has the J for jeans, and here's a third outfit that has a J for jeans. None of the others have the jeans. All right, so what I would do is I could, again, use my favorable over total. All right, so my favorable outcomes are going to be 3 over my total outcomes, which is 9. And if I reduce this, I would have 1/3, or 33%. So again, my probability of choosing an outfit with jeans is 33%. Almost done. All right, it says you can also determine sample spaces from a two-way table, as with the other probability model. So we can tie that in as well. What would a sample space for this outfit situation look like? And show you that option as well. This will be the last one that we do. All right, so again, we'd fill in our table, and we have t-shirt and jeans, we have button-down and jeans, and we have sweater and jeans. We have t-shirt and khakis, we have button-down and khakis, and sweater and khakis, or t-shirt and dress pants, button-down, dress pants, sweater, dress pants. So to do a sample space, we could easily just use the rows and the columns to help us here. All right, so if I'm finding the sample space of jeans, I could say, okay, 1, 2, 3 is my favorable outcomes, 3 outfits with jeans, 9 total outcomes, so it would look like 1/3 or 33%. All right, same thing for khakis, 1, 2, 3 outfits that are favorable, 3 outfits with khakis, 9 total outfits, so again, 1/3 or 33%. And then my dress pants, same thing. I have, oops, this should be a dress pants. Sorry. All right, I have 3 favorable outcomes over my total 9 outcomes, and so that would be 1/3. All right, and then I can do the same thing to deal with the shirts. So this is the sample space for the pants, and then here could be the sample space with the shirts. So again, t-shirts, I have 3 favorable outcomes over 9 total. So again, 1/3. Button down, same thing, 3 favorable outfits, 1, 2, 3, over the total 9, so 1/3. And then sweater, again, 3 favorable over 9 total, so 1/3. So I can use my table to determine that. Certainly you'd want to turn these into percents if you're asked to, since that's the way that we are most familiar with working with these. But again, now I've just created a sample space of my different outfits. All right, guys, you are now going to do your very last your turn question. All right, it says you roll a number cube and flip a coin. What is the probability that you get a 3 and a tails? All right, so I'm going to help you get set up here. And you don't have to do your table like this, but you could. Remember, we put one option across the top, so let's put the dice across the top. So I have an option of rolling a 1, a 2, a 3, a 4, a 5, or a 6. All right, and then along the side here, my options are rolling a heads or a tails. And if I just kind of make a table like this, you could fill in the table and then use it to answer the question. So again, you didn't have to work with it like this. You could have set it up differently. Your table may look a little different from mine, but you know, this is just one option. All right, good luck. I appreciate your patience, and bring your turn questions tomorrow, and your teachers will go over them. Thanks, guys.